Okay, the goal of this recording is to walk through the Unit 1 review worksheet that I gave you. And I know you have the answer key, but it's kind of nice to hear the explanation that goes along with that answer. So that is my plan for this recording. Questions 1 through 12 are examples of solving type problems that you have seen in chapters 7 through 9. So there are several different varieties, so make sure you recognize what type of problem you are looking at before you start solving, because the type of problem dictates the method that you're going to use to solve. Question 1 is a basic linear equation, meaning the exponent is just a 1. It's not an x squared, it's not an x cubed, there's no absolute value, there's nothing like that. It's just a basic equation that has simply x values in it. When you have an equation like this, the goal is to get the x term by itself. To do this, my basic thought process is to simplify both sides as much as possible, then to rearrange the equation so the x's are on one side and the constants or the numbers are on the other side. That is my plan. Left-hand side, 5 minus 2x. There's nothing I can do to simplify that. It's already simplified. The right-hand side, I can reduce the right-hand side. Leave the 4 alone. Do not add the 4 and the 2, because the 2 is touching a parenthesis, and that means to multiply. And remember, you have to multiply before you add in your order of operations. So leave the 4 alone and multiply the 2 times each term inside that parentheses. 2 times 3x is 6x, 2 times 7 is equal to 14. Simplify the right-hand side. Like terms, 4, negative 14. When I put that together, I get a negative 10. You could put minus 10 plus 6x. That would have been fine also. Okay, left-hand side and the right-hand side are simplified as much as possible. So now my plan is to put the variables on one side. So I have a negative 2x on one side, I have a 6x on the other side. I want to put them together. So I'm going to take this negative 2x and move it to the right-hand side. Since it's a negative 2x, I want to do the opposite. And so I'm going to add 2x to the right-hand side. 6x plus 2x gives me the 8x. I have a negative 10 over here. I want to get rid of it so I don't have an x and a constant on the same side. So I'm going to add 10 to the other side. Dividing both sides by 8 gives me my answer. X equals 15 over 8. When you have a linear equation, the goal, simplify both sides as much as possible. Then rearrange your equation so that you have the x's on one side and the constants on the other. Then divide by the coefficient of x, and you're done. Question 2, not a linear equation. Question 2 is a quadratic equation. How do I know? Because the x is squared. When you have a quadratic equation, remember back from 055 and from chapter 7, to solve a quadratic, you have several options. You could factor it. You could put it into the quadratic formula. You could complete the square, but we haven't talked about that a lot. But I'm going to try one of the first two. I'm going to try to factor it. If it doesn't factor quickly, I'm going to dump it into the quadratic formula. Factoring. My possible factors of 4x squared are 4x times x, or it could be 2x times 2x. My first step, what two terms will multiply together to give me the first term? Second step, what two numbers or two terms will multiply together to give me the last term? The only options I have are 1 and 3, or negative 1 and negative 3. Those are my only options. Okay, so I'm going to forget the negative positive thing, just looking at 1 and 3. Since the 3 is positive, since this last term is positive, I know the two signs have to be the same. So this sign and this sign have to be the same. Since the middle term is negative, I know that both of them have to be negative. Next, since that last term is positive, I know that whatever I get, remember in the guess and check technique, I multiply these two terms together and I multiply these two terms together. So whatever I get after I multiply, I add together since that last term is positive. So let's try. Let's put a 1 here and let's put a 3 here. 1 times 4 is 4. 3 times 1 is 3. 4 plus 3, not 8. Try switching them. Put the 3 here. Put the 1 here. I get 12. I know it's not going to work because I'm adding 12 to something and I'll never get 8. This one did not work. Go to the next one. Try a 3 here and a 1 here. I get 6 and 2. That is 8. When I add 6 and 2, I do get 8. So there are my factors. My factors for this are 2x minus 1 and 2x minus 3. Now that I've factored, I have to figure out what makes each factor 0. So I have to ask myself, when will 2x minus 1 equal 0? And I can write an equation just like that and solve it. I add 1 to both sides, divide both sides by 2, and x equals a half. So this first factor will be 0 when x is a half. What does that mean? This will be 0 when x is a half. Remember my goal. This says what value for x will make this side equal 0. If I plug a half into this first factor, and I plug a half into this second factor, the first factor is 0. The second factor is not 0. The second factor, if you work it all out, it's a negative 1. But remember back from basic math, 0 times anything is 0. So my goal is to make one of the factors 0, because 0 times anything is 0. So when x is a half, my expression is 0, which is what I want, because it says when will the left-hand side equal 0? One time when x is a half. Now, it doesn't matter which term is 0. If the second term is 0, then if I multiply 0 times anything, I still get 0. So, question number 2, what value for x will make the second factor 0? And if we use a little shortcut, we notice that this 1/2 is simply the second term divided by the first term, but the opposite sign. This was 2x minus 1 equals 0. And it became a positive 1 divided by 2. So if it's 2x minus 3, it becomes a positive 3 divided by 2. And that is my other value for x. If you were to plug those two values back into the first equation, you would get 0 in both cases. You have two answers in most quadratics. Okay, question 3. Kind of got to look at question 3 to see what kind of equation it is. Even though it looks all weird, it really is just a linear equation with a bunch of fractions. Two ways we can do it. We can do it like question 1. Simplify the left-hand side and the right-hand side as much as possible, and so on. Or, to simplify, we could clear all of our fractions, and that makes it a little easier to work with possibly. So, step 1, I could look at the equation, use the equation just like it's written, combine my like terms, do all that good stuff. Step 2, or technique number 2, multiply everything by the common denominator so that I can clear my fractions and then make it a different type of linear equation where I can solve it the same way. That's my technique I'm going to use. I'm going to multiply everything by the common denominator, 15. Multiplying 15 times 2x over 5. Forget the x for a second. 2 over 5 times 15 over 1. The 5 goes into 15 3 times. The 5 goes into 5 once. That will always happen. Why? Because you picked 15 as a common denominator. Okay? Now I just get 2 times 3, which is 6. Stick the x with it. 1/3 times 15. Just like we said before, this bottom term will always go into the 15. And it's just going to be 5 times 1. If your fractions do not go away, you did something wrong. Because you picked a common denominator, they have to go away. That's why we multiply by the common denominator, is to get them to go away. That is the goal of doing that. Multiplying 15 times x over 3 gives me 5x. Multiplying 15 times x is just 15 times x. Multiplying 15 times a -1 is just a -15. If you don't like that technique, don't use it. Just use your fractions the way they are. Get a common denominator, combine your like terms, and all that good stuff. Okay, now question 3 looks very similar to question 1. We're going to simplify the left-hand side and the right-hand side as much as possible. Right-hand side is already simplified. Left-hand side, combine my like terms. Put the variables on one side. I'm going to subtract 11x from each side. Add 15 to both sides. To get rid of that 15, divide both sides by 4. And we have our answer, x equals 5. Okay, question 4. To solve question 4, first problem, those absolute values, those straight lines, are not parentheses. They are absolute values. They mean something. It means whatever's inside the absolute value, make it positive. So if I had a -5, my answer is 5. If I have a positive 5, my answer is 5. So using that logic, the question 4 asks me the absolute value of what equals 5? Well, the absolute value of a -5 is 5, and the absolute value of a positive 5 is 5. So when I get rid of the absolute value, I have to set it equal to both 5 or -5. Run out of room. Why? Because if x is such that it makes the inside 5, or if it makes it a -5, both of them, when I apply the absolute value, will become a positive 5. So what value for x will make it equal to 5? And I solve that one. Add 4 to both sides. Divide by 3. If x is 3, the absolute value of 3x minus 4 will give me 5. Solve this one. Again, add 4. Divide by 3. Whoops. Divide by 3 correctly. If x is a -1/3, then what's inside the absolute value will be a -5, but the absolute value will make it what I want, which is a positive 5. Two answers for the majority of the absolute value questions. When you get rid of the absolute value, to eliminate the absolute value, you split them into two equations. What's inside equal to 5, and what's inside equal to a -5. Take the negative and the positive, what it's equal to. Okay, question 5. We have one concept we have to do, or one step we have to do before we can do what we just did. In order to get rid of the absolute value, in order to split those into two pieces, you have to have the absolute value isolated. meaning it has to be just absolute value equals something. Well, I have this 2 and I have this 5 I have to get rid of. So treat it just like any other linear equation. In order to get rid of the negative 5, which I have to get rid of the plus and the minus first before I get rid of multiplication and division, right? If this said 2x minus 5 equals 7, my first step is to deal with the 5, not the 2. Same concept. So add 5 to both sides, divide by 2, and now I have the absolute value isolated. And now I can split them into two pieces in order to solve. So I take what's inside the absolute value and set it equal to 6, and I take what's inside the absolute value and set it equal to a negative 6, because if either one of those are true, then the absolute value makes it a positive, and we're good to go. Subtract 4, divide by negative 1, and I get x equals a negative 2. Subtract 4, divide by negative 1, and I get x equals 10. Two answers, negative 2 or positive 10. Question 6. Very similar concept to questions 4 and 5. Difference is I have an inequality, not an equal sign. So I still split it into the two pieces. But when I go over here and I split this one, I have to set it equal to a negative 9 and switch the inequality sign. It did say 2x minus 5 is less than or equal to, but when I apply the negative sign to it, I have to flip the inequality sign. One way to think about that is when you multiply or divide by a negative, you flip the inequality sign. Okay, and so you can kind of think about it that way. And that'll help you remember. Next thing, if this is a less than, if it says the absolute value of something is less than, this will be an and statement. If it said the absolute value of something is greater than, it would be an or statement. I'll explain more about that here in a second when we're done solving. Okay, this will be an and. So solve just like we did. Add 5 to both sides. Divide by 2. Add 5 to both sides. Divide by 2. Now, remember, it is an and statement. I don't ask you to graph it, but when I graph it, it helps visualize what we're talking about and the difference between the and the or. Here's what it says. I want all x values that are less than 7 or equal to. And at the same time, greater than or equal to a negative 2. I want all x values that make both of these sentences true. It has to be less than negative 7 and greater than 2 at the same time, so it is everything in between a negative 2 and 7. To write that as an inequality, I put the x in the middle, I put the smaller number on the left, I put the larger number on the right. X has to be greater than or equal to a negative 2, but less than or equal to 7. Everything in between the two. When you write it like this, you are implying an and. If someone reads your paper that you wrote it just like that, they would say and. Now, if I solve this as an or, I get this. X has to be greater than or equal to 7 and, not and, or less than or equal to a negative 2. If I were to solve that inequality above, this one right here, if I were to solve that, this is what I would get. X is greater than or equal to 7, or x is less than or equal to a negative 2. What does that look like on a number line? Here's a negative 2. I want everything less than or equal to a negative 2. And I want everything greater than or equal to 7. It has to be an or, because It cannot be greater than 7 and at the same time less than a negative 2. Not possible. It has to be an or else it has to be no solution. So if it looks like this, it is an or statement. If it looks like this at the beginning, it is an and statement. Okay? Okay, you do need the and the or because they do mean different things. So make sure you put that in there. My eraser's going slow. Okay, question 7. Question 7, we have what's called a compound inequality. We need to solve both of them at the same time. So if I just had the 5 minus 3x is less than 20, to solve that we would subtract 5 from both sides. If I just had the 5 minus 3x is greater than a negative 4, again I would subtract 5 from both sides. So to put them together, I'm simply going to subtract 5 from everything. Subtract 5 from here, subtract 5 from here, subtract 5 from here. These go away to leave a negative 3x in the middle. 20 minus 5, negative 4 minus 5. Divide both sides by a negative 3. Remember, when you are dealing with inequalities, when you divide by a negative, you flip the inequality sign. A negative 9 divided by negative 3 is 3. The inequality sign switches. Negative 3 cancels in the middle, I just get x. When I divide by a negative, the inequality switches. 15 divided by a negative 3 is a negative 5. On a number line, what does that mean? X has to be greater than a negative 5, and at the same time it has to be less than 3. I want everything between a negative 5 and 3, which is kind of the way my sentence is written. X is in between the negative 5 and the 3. If I were to rewrite this, I would flip the order simply because typically you put the smaller number on the left. Doesn't matter, it's not wrong, but you will see it written that way more often. Okay, question 8. Remember, on any of these, if you get stuck, if I'm going too fast, hit pause, listen to it again, rewind it. If I'm going too slow, fast forward it, whatever you need to do. Question 8, back to a quadratic. Difference is it's a quadratic that has just one x value. In this case, one x squared value. So my thought process is different. I'm not going to set it equal to 0 like I did back in question 2. I'm going to get the x term all by itself and just simply solve it. If there is an x squared and an x like question 9, I can't do it that way. I have to set it equal to 0 and use one of my techniques like factoring, quad form, etc. But if there's only one x term like in question 8, I can isolate that term and solve. First step, to isolate the squared term. I'm trying to get this term by itself. So really what I'm looking at is something like that. Oops. Something like that. Okay, so my first step, add 5 to both sides. So I have 2x minus 3 squared equals 18. Second step, divide by 2, and I get x minus 3 squared equals 9. Now, what number squared is 9? To get rid of that square, I am going to square root both sides. So the square root of 9 is 3. So x minus 2 has to equal 3. But there's another number. When I square it, I'll get 9. If x minus 2 is equal to a negative 3, I'll also get 9 because a negative 3 times a negative 3 is 9. So when you eliminate the square, you have to get both the plus and the minus of the square root. So when will x be 3? Or when will x minus 2 be 3? When x is 5, add 2 to both sides. And over here, add 2 to both sides gives me a negative 1. So I get 2 answers for that problem as well. X equals, whoops, this wasn't a 2, was it? This was a 3. You're probably wondering what in the world I was doing. If x minus 3 equals 9, so x equals 6, and x equals 0. A little better, sorry about that. And so I get 2 answers. Okay, question 9. Looking at the problem, it is a quadratic. Like I said before, there's not a single x term. There's both an x squared and an x. So I have to use the technique of setting it equal to 0. So setting this equal to 0, I move the 7 across, and we get 3x squared minus 5x minus 2 equals 0. Again, before I go to quadratic formula, I'm going to factor first. Factoring 3x squared, etc. My first step is to figure out what two things will multiply together to give me 3x squared. Unlike the problem above, we only have one set of things that will multiply together to give me 3x squared, and that's 3x and x. Next step, I go to the 2. Factors of 2 are 2 and 1, and that's it. Since the 2 is negative, my two numbers here are going to be opposite signs. This sign and this sign will be opposites. I don't know which one's positive and which one's negative yet. But I do know whatever I put into this position gets multiplied by the 3. Whatever I put in this position gets multiplied by the x. And I take those products and I subtract them to give me the 5. Why do I subtract? Because that is negative, and since that is negative, my signs are different, and when my signs are different, I subtract. So, what two things will multiply together to give me 2? 2 and 1. 3 times 2 is 6, 1 times 1 is 1, and 6 minus 1 is 5. Erase some of this to make it easier to see. So here's what I have. I have 3x, x, I have 2 and 1. 3 times 2 is 6, 1 times 1 is 1, 6 minus 2 is 5, but I want a negative 5. So my question is 1 minus 6 a negative 5, or is 6 minus 1 is negative 5? Well, clearly 1 minus 6. So I need the 6 to be negative, which means the 2 has to be negative, and the 1 has to be positive. Hopefully that is not brand new. Hopefully that's a refresher, again, back from 055. Next step, like we talked about before, my little shortcut is x equals the opposite of the second number, so negative 1, divided by the coefficient of the first one. So negative 1 divided by 3 is what makes the first factor 0, and the second factor is 0 when x equals 2. And there's your two answers. Question 10. First step, recognize it's a linear equation. My goal, simplify the left-hand side, simplify the right-hand side as much as possible. Done. Step 2, make all or arrange it so that all the x's are on one side, all the constants are on the other. Get rid of the 5. Add 5 to both sides. So 2/3 x has to equal 9. Next step, I have to divide by the coefficient of x. I have to get rid of this 2/3. It's pretty easy if it said 2x equals 9. I would divide both sides by 2. That's easy. How do I divide by 2/3? My steps are the same whether it's a fraction or a whole number. I divide by what's in front of the x. Remember your fraction rules. To divide by a fraction, I multiply by the reciprocal. So I will multiply both sides by the reciprocal. Left-hand side, everything cancels like we want, and I get x. Right-hand side, when you multiply fractions, you multiply the top and you multiply the bottom. Cross simplify first if you can, but we can't, and so we're done. Answer x equals 27 over 2. Don't let fractions confuse you. The steps are the same, you just have fractions to deal with, but nothing's different. Number 11 and number 12. Solving equations with square roots, or what's called radicals in them. I'm going to do 12 first because it's easier, and then we'll use that logic to do question 11. First step when solving an equation that has a square root in it. Get the square root all by itself. So in this case, I have to get rid of the negative 4. So I'm going to add 4 to both sides. Next step. Remember when we had x squared equals something like 9, and I said x equals 3, or x equals negative 3, because we took the square root to get rid of the square? Well, if a square root undoes a square, then a square must undo a square root. So to get rid of the square root, I am going to square both sides. Now, a square times a, not square times, but applying a square to a square root causes it to go away. Example, square root of 5, no, square root of 25 squared. Square root of 25 is equal to 5, and 5 squared gives me 25. So the square and the square root, they cancel each other out, and I just get what's inside. Same logic. Up here, the square and the square root cancel each other out, and I get what's inside of the square root sign. But what I do to one side, I have to do the other. So if I square the left-hand side, I have to square the right-hand side. And 5 times 5 is 25. Now we're down to a basic linear equation. Subtract 6, divide by 2, and x equals 19 over negative 2. Question, and if you look at my answer key, I have it the other way. You won't see a negative on the bottom very often in a textbook, in an article, anything like that. It normally goes on top. That's why I put it up there, but either way, it's technically correct. Question 11. In order to solve an equation that has a radical in it, a square root symbol, I get the square root symbol by itself and then square both sides. Problem with question 11, I have two square root symbols. I can't get them both by themselves, so I have to pick. Get one of them by themselves. I'll leave the y plus 21 alone on the left-hand side, and I'll move the square root of y to the right-hand side. Meaning I'll subtract square root of y from the left-hand or the right-hand side. Now I have one of the square root symbols by themselves, so my goal is to get rid of the square root symbol. How do I do that? I square the expression. But if I square the one side, I have to square the other side. Notice I don't simply square each term. I'm squaring both sides. Side note, 5 equals 2 plus 3, correct? If I square this side, and if I square each term over here, do I get the same answer? 5 times 5 is 25. 2 times 2 is 4. 3 times 3 is 9. 9 plus 4 is not 25. But if I don't square each individual term and I simply square the whole thing, then I do get the same answer on both sides. So when I say square both sides, do not simply square each side. Sorry, each term in the sides. I have to square the whole side. Left-hand side is easy. The square root and the square cancels, which is what my original goal was. Next thing. I'm squaring 7 minus the square root of y. Square means multiply each term by itself. Remember I had the 2 plus 3 equals 5. Wow, I didn't say that right. No, remember I had this mess here. I can't simply square the 2 and square the 3 because I don't get 5 squared. I have to multiply this term by itself. This one's easy because what I get inside is simply a single number and I can multiply 5 times 5. This top is not as easy because I can't combine the square root of y and 7. Can't put those together. So I have to go back to multiplying two factors together. And I do our FOIL technique. So I need to multiply the 7 times the 7, first term, 7 times the negative square root of y, outside terms, multiply the inside terms, negative 7 square root of y, and multiply the last terms. I have to FOIL. Square root of y times square root of y is just y. Negative times a negative is a positive. When you have two terms being added together, one inside the radical, one outside the radical, you must FOIL the two expressions together. You cannot simply square each term. Okay, now that I have this, if I look at this mess, what I notice is I still have a square root, but now I only have one instead of two. So my goal is exactly like question 12. I have a single square root. My goal, get that square root all by itself. So I can square both sides and get rid of it. So let's do that. First step, let's put all the y's on the left-hand side. To do that, I'll subtract y from both sides. When I subtract y, that goes away. When I subtract y, oh, that was nice. That goes away. That helps. Get the constants on the same side. 21 minus 49 gives me a negative 28. Right-hand side, I can put these two things together. And this goes a little bit further up into chapter 7, or chapter 8 and 9. When I have the same term underneath the radical, I can add the coefficients together, and I get negative 14 square root of y. My goal, get the radical by itself. So I divide by negative 14. And so 2 equals the square root of y. Square both sides, and y equals 4. Question 11 and 12. Get the square root term by itself. Square both sides to isolate it. If you have more than one, get one of the square roots by itself and square both sides, and then solve. Question 13. Give me a second to erase this mess. Question 13. Systems of equations. Question A, I just have two variables, so I have two equations. Question B, I have three variables, so I have to have three equations. First step, I got to pick the technique I want to use. Do I want to use elimination, where I add the two equations together and get a variable to cancel? Or do I want to use substitution, where I solve for a variable and then substitute that in to the other equation? Looking at A, I notice it's already set up nice and neat for substitution. So that's what I'm going to do. If I wanted to use elimination for question A, I would have to move that negative 3y to the left-hand side so my x's and my y's and my constants all line up in the same order. It does not matter what order they're in, but they have to be in the same order. With that said, I could also move the 2y in the first equation to the right-hand side so that the x's and the y's and the constants line up. I think that's more work, than doing substitution. So I'm going to use substitution. First step, I'm going to substitute in what x equals, because it tells me x equals a negative 3y plus 1, and I'm going to plug that in for x. So I have 3 times x, which is now the negative 3y plus 1. Continuing on with the rest of the first equation, I have that mess. I simply plucked out the x in the first equation and inserted what the x equals from the second equation. Just like if it said x equals 4, I would substitute the 4 in for the x. I just now have an expression for what x equals, and so I'm going to still substitute in that expression for x. Now solve. Distribute. 3 times a negative 3 is a negative 9. 3 times 1 is 3. Back to question 1. Simplify the left-hand side as much as possible by combining like terms. Put the variables on one side, put the constants on the other. Divide by the coefficient, and you got it. Not done. We know what y is, but when you solve a system, you're finding the values of x and y that make the equation true. So I have to find the value of x. I can plug it into either equation, either the first equation or the second equation. The second equation is nice and neat because it tells me x equals something. And if I simply could plug in the y value, I would know what x equals. Well, now I know what y is, so I can substitute that in for the y. So negative 3 times 3 is a negative 9. Combine like terms, and x is a negative 8. So when x is a negative 8 and when y is 3, both the first equation and the second equation are true. And that is the goal of solving the system. Question B, not quite as easy. Goal's the same. I want to find the values for x, y, and now z that make all 3 equations true. And again, I can use substitution, I can use elimination, or a combination of both. For solving a system with 3 equations, I would highly recommend using elimination first. You can do it the other way, but it makes a big mess in my opinion. So looking at that, I want to try, and here's the key, I want to not just try, I want to eliminate the same variable from 2 different sets of equations. So I notice if I add these 2 equations together, the first and the second, my y's go away. If I add the first and the third equation, my y's also go away. And I will end up with 2 equations with the same 2 variables. And I'm back to question A. That's my goal, and that's my plan. So add the first 2 equations together. X plus x is 2x. Z plus 2z is 3z. 4 plus 1 is 5. Add the first and the third equation together. X plus x is 2x. Z minus 3z is a negative 2z. Positive 4 minus 4 is equal to 0. The y's are eliminated in both cases, and we're down to x and z in both equations. And now I'm back to solving a system with only 2 variables. So looking at that, do I want to use elimination or substitution? In this case, I'm going to use elimination, because it doesn't say x equals or it doesn't say z equals. If it did, I would use substitution. If I add 2x to 2x, I don't get 0. Notice up here I had a positive y and a negative y, so those canceled. If I add 2x and 2x, I don't get 0. But if one of those were negative, if they were opposite signs, and I add them together, then they would cancel. So I'm going to simply multiply everything in the second equation by negative 1. And when I do that, both signs change. I also multiplied the 0 by a negative 1. It just doesn't change signs. So when you multiply by a negative 1, make sure you change all of the signs. Now, add the two equations together. 2x minus 2x is 0. 3 plus 2 is 5. 5 plus 0 is 5. Dividing by 5, I get z is equal to 1. Now that I know z, I will plug z back into either of these equations here. I'm going to pick the top. 2x plus 3 equals 5. Subtracting 3, 2x equals 2. Dividing by 2, x is also equal to 1. Going back to any of the first three equations where there's an x, a y, and a z, plug in x and z. I'll go to the first equation. Plug in 1 for x, plug in 1 for z. Combining like terms, doing a little solving, skipping a couple steps, we can see that y equals 2. When you solve a system of three equations, eliminate the same variable from two different sets of equations. Solve the system of two equations, plug those two variables back into one of the three equations, and solve for the third variable. You must have all three variables. Okay, question 14. Question 14, graph the system of inequalities. Going to use two techniques. Going to use the xy intercept technique and the y equals mx plus b technique. When you have an equation that looks like the first one, I like to use the xy intercept technique. To do that, I substitute in a value for x, not just a value. I substitute 0 in for x to find the y-intercept, because everywhere along the y-axis, my x value is 0. So plugging in 0 for y causes that to go away, because 2 times 0 is 0. So when y is 0, x is equal to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When y is 0, x is 10. When x is 0, it causes this expression to go away, or that term to go away. Dividing by 2, and y equals 5. Okay? Connect my dots. Since it is less than or equal to, it is a solid line from there to there. Since it is less than, I am going to shade below that line. Notice I only put arrows because I want ultimately where all of these intersect, and I don't want a big mess, so I'm just going to put arrows before I start shading a bunch. Next, using y equals mx plus b. When x is 0, y is 12. My y-intercept is up here at 12. My slope is a negative 3, meaning I go down 3 and over 1. I do that a few times. If I were to go down 3 and over 1 several times, I get down here. Whoops, too far over. I get down here, down 3 over 1, down 3 over 1, down 3 over 1, to a y or x-intercept of 4. So connecting my dots, again, it's a solid line. And I'm shading below that one as well. Made a mistake already. Problem is, it should be dotted. Why is it dotted? Because the y is simply less than, not less than or equal to. If it is less than the line, I want everything, I want all the y values that are less than the line. Look at this as the line. So when I read my sentence, I want all of the y values that are less than my line. That was a pretty important statement. I want all my y values that are less than my line. That's how I read that when I read that across. So if this is a y value on my line, I want everything less than that y values. The y value on the line, what's below that is less than, what's above that is greater than. So I'm shading everything that is intersecting between those two equations. It says simply x is greater than 0. Sorry, I got to keep going down. It doesn't say anything about y, so actually I can shade all of that. Okay, and there is your question 14. 15. Lots of stuff in 15. I'm going to have to split this recording. It's getting kind of long. I want to check, see what I got left. Yeah, I'm going to split it after question 15, and we'll do a second part. Otherwise, that's going to be a long download. Question 15. Find the equation of the line with the given characteristics. We are going back to y equals mx plus b for question number 1, or question letter A. Y equals mx plus b. Remember, in this expression or this equation, the m stands for the slope, the b stands for the y-intercept. So y equals 4x plus b. I know the slope is 4, so I plug it in for the m. I got to find the b value. To find the b, I pick the x and the y and substitute it in for x and y. The x is a -3 and the y is 1. So I plug those values into the correct place. Multiply 4 times 3, add 12, and b is 13. So my final equation, y equals 4x plus 13. When you are solving these, to find the equation of a line, you need the slope and you need the y-intercept. Once you find both of them, plug them in, and you got it. Question B, like I just said, I need the slope and the y-intercept. Why did they give me the line or the equation 2x minus 3y equals 7? In order to find the slope. Parallel lines have the same slope. So if I want the equation of a line that is parallel to 2x minus 3y equals 7, it must have the same slope as 2x minus 3y equals 7. So that raises the question, what is the slope of 2x minus 3y equals 7? It's not in the right form. So let's put it in the right form. I want the y by itself. So I'm going to have to subtract the 2x. Divide by -3, and a negative divided by a negative is positive, and a positive divided by a negative is a negative, and there is my slope. I don't care about the 7/3. What I need from that equation is my slope. So the equation of a line parallel to this one will have the slope y equals 2/3 x. But I don't know the b value. I got to find the correct b value so that the second part is true, so that it passes through 6/2. Plug in 2 for y, plug in 6 for x, and solve. Fraction times a whole number, put the whole number over 1. Cross simplify, 3 goes into 3 once, 3 goes into 6 twice. Subtract, and b is a -2. Plug all that back in. Y equals 2/3 x minus 2. And you have your equation. Question C. I don't give you the slope. I don't give you the y-intercept. So you're going to find both of those. In question B, I didn't give you the slope either, but I gave you a way of finding the slope. In question C, I don't give you the slope, but I give you a way of finding the slope. Remember the definition of slope. Change in y over change in x. Or y2 minus y1 over x2 minus x1. Doesn't matter which one's the second y or the second x. Just pick one of them. But once you pick the y value as the y2, then that x value that goes with it is the x2. So I'll start with the -5, and I'll subtract the 4. Since I did that, I have to start with the -1 and subtract the 2. -5 minus 4 is a -9. -1 minus 2 is a -3. And when I divide, I get a slope of 3. And now I'm right back to what I did in question A. I know a slope. I got to find the y-intercept. In this case, it doesn't matter. Pick either point and plug it in. Solve, and b is -2. Take the -2 and plug it back in, and you got it. Okay? Question D. Why did I give you the equation y equals 3x minus 4? To find the slope. Perpendicular lines have opposite reciprocal slopes. So what is the slope of y equals 3x minus 4? My slope is 3. So my perpendicular slope is a -1/3. I flip my fraction over. Well, it's not a fraction. To make it a fraction, I put it over 1. So I flip my fraction over, and I take the opposite sign. It was positive, now it's negative. Perpendicular lines have negative or opposite reciprocal slopes. Once I know my slope, I can find the equation just like we've been doing in all these other problems. Plug in 1 for y, plug in 9 for x, and solve. Plug the final equation in, and you got it. Okay? Okay, I'm going to call that good for right now, and I will pick back up in part 2 in question 16 to the end. Yeah, there's still a lot to come.